Oh, guys, I already finished the electrical performance of the TPA3255, and I supposed to stop taking the electrical performance already, but someone really requested me that what about other board? They say that other TPA3255 do not perform the same, even though they are the same chipset, main chipset from Texas Instrument. It's just because the other manufacturer make a cheaper board, something like that. And what about the performance? Maybe it's good to take a look at those kinds of board, like the original board that I have, like this one, the first one that I obtained from Taobao, that is the e-commerce inside China. And I get another one in here, which is the form factor is a difference, but it close a similar design. So I don't know the performance of this. Probably this is the one that they are interested in, and the reason why is because it comes with a tag price of cheaper than the module B or the module A. Look at that. Look at the massive difference in terms of size and form factors. So without further things to do, I'm going to substitute the module B into module C, and let's see what's the electrical performance. 3, 2, 1. Okay, we good. We good. There you go. Put that into 1 watt of power. Okay, that's 1 watt of power. I don't like it so much. It's not so nice. I can see the artifacts already in here. It's pretty obvious. This is the module C, and it's smaller, including those inductor over there. From that form factor, I don't like so much the output signal, wherein you can see that artifacts are so evident at about 1 watt of power. Well, I smell something. Is it burning now? The temperature is at 36 degrees centigrade, so it should not be. Maybe our neighbor is cooking right now. Well, this is how it looks like the artifact, which is not good to my eyes. I'm talking about the artifacts in here, which is not pretty nice as compared to the other module. Maybe that is a 1% distortion, and this is 10% distortion, which is also 33, 33 volt RMS. And let's see both the channels. I'm gonna put the 1 to 50. So see both channels. Maybe this is 1%, 2%, 10%. That's not an issue. I think just the observance of the artifacts at lower power, like 1 watt, that is something that I can observe. Well, I think that at 47 degrees at the surface of the heatsink, this power amplifier can survive for some like maybe 5 minutes right now, and immediately crank the maximum power output to be found to be 33 volt RMS across the 8 ohms resistive load. That will give you also about 136 watt of power, which is also decent, I should say, which is, sorry for the English pronunciation, it's not so nice. Well, that's it. That's it. 48 degrees centigrade. Is it properly coupled? That's how it coupled in there. It should be. I think it's also nice. It's also decent. Module C. And let me enable the distortion of 19 volt RMS output. We get a pretty nice distortion also of about 0.076 for the left channel, and the right channel is even much better at 0.00591. Pretty good, right? At 66 degrees centigrade at the 67 degrees centigrade, I should say, at the surface of the heatsink. Again, I'm putting my hand. In any case, I can see smoke. I can smell something that is not desirable. But it seems it's okay. There's no problem on it. 68 degrees. 68 degrees. There you go. Wow. I think I like this one. I like this performance. In terms of temperature only, that it did not so easy to go for a thermal protection, not like the Module B, which is easily get into thermal protection. But this one, it looks like it will not. 120 power input in here, and 19 volt RMS is about nearly 100 watt. Stereo, that is 50 watt per channel, and we're losing about 20 watt of power actually, which is better than the other module, the module B. Really, really, I can't believe that. I need to see the data to prove that this amplifier actually is small but terrible. Is basically better in terms of efficiency than the module B. So where is the module B right now? So this is the module B. This is the module A, and really, that's really something that I can observe right now. And 81 degrees centigrade is still working good. Guys, I told you that this power amplifier in here, I thought that because of its small form factor, I was wrong. I was wrong to judge it. That I judged the book by its cover, but finally it performs well. It's really performs well. That even though at 83 degrees centigrade right now, the temperature protection is not enabling. Why I say that is because I test the module B with the same condition like 100 watt output power. There is a 50 watt per channel, and then it's not going into the protection mode, even though it's already 84 degrees centigrade. The other module, once it reaches 80 degrees centigrade, it goes into protection mode. Another thing that I observe is that the efficiency seems better for this power amplifier. That it only loses about 20 watt of power. Like I got 100 watt output, my input is 120 watts, so you lost about 20 watt of power in there. The module B is a different story. That I have the same 100 watt of power output, but the power input is about 140. Let me double check the data. Let me double check the data to really compare that. I might be wrong. And it's really quite good. It's still maintaining the output of about 19 volt RMS at a pretty good distortion. Guys, probably you're asking a question about what I'm doing right now. Basically, this is not a soft test. I just wanted to understand about the temperature protection of this module. It is the module C. I just call it module C because it's small form factor, and I thought that it won't survive for a test. Now it's 88 degrees and still able to perform better with a good distortion output and so on and so forth. The thing that probably is a question is that sine wave is not equivalent to music. Music is instantaneous. We got lows, we got high, and suddenly become big. That kind of what we call as from high to low, or from low to high. It's called dynamics, and this is not really equivalent to the music. But using a music is not repeatable, and that's the reason why we're using sine wave. Using sine wave because the output will be repeatable. And amazingly, that it's really disappoint me. Really, that it really disappoint me that this small class D power amplifier in here, this one in here, disappointed me. That my prediction is really exceeding my prediction actually. That really disappoint me. I'm telling you guys that I was disappointed because this TPA3255 module C did not go into the temperature protection mode when it reached the heat sink to about 70 degrees or 80 degrees centigrade. And it's still powering up right now at 84 degrees centigrade at my back. I'm wondering what is the reason why. Maybe there is some adjustment in the hardware or the IC has been damaged that it cannot protect itself. 14 minutes, we've got 87 degrees centigrade at the surface of the heatsink. I really need the electric fan right now because these power resistors, they are actually very hot right now. So I need to cool them down with this electric fan. It's awesome, guys. It's awesome. 52 minutes can survive. There you go. Oh, I realized that what is happening actually. It seems that the LED is only one right now. My observation. Let me confirm that one later. 52 minutes. It survived. We've got still 19 volt RMS output at the 8 ohms resistive load with that kind of distortion, which is a pretty good 0.0084. And I stopped the electric fan because somehow it affects the temperature reading 95, 94 degrees centigrade. There you go. My only concern right now is that the LED seems only one lighted right now. What's going on? I need to understand about the one, and I can smell something is really boring right now. So probably I need to open once again the electric fan. It's because of this. It's really hot right now. 2, 1, 60 minutes. There you go. It survived. It survived the precondition based on FTC Title 16 Part 432 and still able to maintain a good output of voltage swing here. And this is pretty cool. Pretty cool. I love it.